Hello guys, I am 𝗙𝗲𝗃𝗃𝗃𝗃. Welcome back to Smart Interviews YouTube channel. Today, let's see few problems on Codeforces Round 993 Division 4. Let's start with the first problem, which is an easy problem. So you're given like a cube is given a number n, integer n. She wants to know how many ordered pairs of positive integers a and b there is such that a equal to n minus b. Okay, since Q is not very good at math, please help her out. So if you see, the constraints are quite normal, t going from 1 to 99 and going from 2 to 100. So if you see in the input and output format, let's check the input output format. So so if you check, for these are the number of test cases, and let's say for input 2 you are given that okay, we already have here the output is only 1 and 1, but for input 4 you are also given here like you have 3 1, 2 1 and 1 3. So they are not given for input 6. Let's also see for input 6. For input 6, if you observe, the output can be like 1 comma 6, and also I can tell like 6 comma 1. Okay, not 6 comma 1, 5 1 comma 5 and 5 comma 1. I can also tell like 2 comma 4 and round way 4 comma 2, and what else, 3 comma 3. So if you observe, for 2 the output is 1, for 4 the output is 3, for 6 the output is 5. Do you observe any pattern here? If you take any number, let's say x equal to 7, or let's say x equal to 10. So here I have taken a bigger number. For this, the expected output are like 1 comma 9, 9 comma 1, and 8 comma 2, 2 comma 8, 3 comma 7, 7 comma 3, 4 comma 6, 6 comma 4, and 5 comma 5. So any possible input you take, you are getting like, for 10 the output is like 1 2 3 4 5 6 7 8 and 9. Can I say that the output is simply, can I in a general form, can I say that output is simply n minus 1, or let's say whatever the input is minus 1? So I hope the code will be very easy. Let's quickly see it. So I am using the by default custom test case given by Codeforces. So since we are using Java, we need a scanner class to take the input. So read the number of test cases till my test cases are not equal to 0. I will read n, and yeah, my output goes like n minus 1. Let's copy the inputs and give in the input box. If I run, yeah, 1 3 and 5, which is expected. Now you can simply copy your code here, come submit your code, submit. accept. So that was quite simple. Okay, so let's start with the second problem, normal problem. You're given a string which has only characters p, q, w. Okay, is painted on a glass of a store. Ship walks past the store. Okay, ship is like crossing the store and standing directly in front of it and observes a string A. Ships then ship then heads inside. Okay, ship was looking from the outside. Now ship is going to look from the inside. At that time, he observes a string B. So overall, what your problem statement is? Ship is giving a string A. Your job is to find the string B. In the input, again, like test cases are quite normal. The only line which contains, okay, you're given string A, directly one word string A, which he has observed from the outside. In the output, you need to return string B, which ship has observed from the inside. So let's see the test cases. If you observe, for 𝗙𝗏𝗃, it has changed to 𝗙𝗏𝗃. So it is clear that if you are having P, change it to Q. If you are having Q, change it to P. And the second example also tells the same. But when I come here, I am getting the exact same input as my output. So if you look here carefully, okay, if you see the fourth input and output, you can see that it is somewhat like first W is being intact. So W, let's do this first. W, P, Q, P, W, and let's continue this. So ideally this, we thought it should be the output by replacing P with Q and W is same. But here we got somewhat different. If you observe, if you look from the string, if you look through the mirror in the other way, it will be reversed, right? If you reverse this, what are you going to get? You will get like Q, P, W. This is nothing but our output string, can I say? Yeah, it clearly satisfies our output string. And the input, if you can also check the same thing with the last input. So overall, the problem statement is quite clear. First thing, first thing, change P to Q and Q to P. W will be same. Second step, reverse string. Simple. So let's directly go to implement it. So yeah, I'll just clear this out. In the input, this time I am given only like a string A. So 𝗟𝗏𝗃. So now the first step, I will replace P with U. So for this, I am using a separate string. Let's say a temporary string. So first thing, I will iterate on the string for I going from 0 s dot length. Okay, not s, a dot length. My bad. Now, next step, I will just check if my a dot caret I equal to P. Okay. Okay, my opening brackets have gone. If it is equal to P, in the temp, I will add Q. else if my a dot caret I, if it is equal to q, I will add simply p. Else it will definitely be w. Why? Because we only have two strings. We have only three characters, w, p, q. So yeah, it will be w. So step 1 is done. Let's go to step 2. In step 2, we need to reverse the string. So I will reverse, so I need a string b. I will store my answer in the string b. So now I will simply reverse the temporary string. So I will start my iteration from the back for I equal to temp dot length. Okay. Yeah. One more thing. It's a method if I'm not wrong. I greater than or equal to 0. So for my B string, I will simply add the temp dot character. Now let's print our B and let's cross check with our input. Okay, I hope it should not take this much time. It should not give TLE at any point. Let me just rerun my code. Okay, there is one thing, yeah. Temp. Do we have any more errors? Yeah. Print. Any more errors? No. Only two. Yeah. Did we get the same expected output? Yeah. PWP for QWQ, all Qs, and our fourth. Yeah, looks correct. Let's submit our code. Yeah. So it was also like easy level of problem. Let's see some other problems. Okay, so this is the hard problem. So in this problem, like I'll just zoom. Um, there is a teacher in a paperful university. The seats of his classroom are arranged like in a two rows, and like each rows having m seats. And there are like three kinds of maybe monkeys, and he wants to assign as many monkeys to sit as possible. So definitely there is a condition. So ball knows that A of them only want to sit in the first row. Okay, row 1. B of them only want to sit in the row 2. C of them have no preference. They are ready to sit anywhere. Only one monkey may sit. Okay. They can't sit on top of each other. Only one monkey in one seat. And each monkey's preference should be followed. Okay. You need to find the maximum number of monkeys that ball can seat. A ball can make them seat. So yeah, the inputs are now like quite high, 10 power 4. You should be careful. and each time you are given, like for each test case you are given four integers m, a, b and c. So, and the values are also quite like till going till 10 power 8. So let's see the test cases. If you see the test case 1, it's clear that you're having two rows. Each row has a capacity of 10. This is A, B, C. A in the first row, B in the second row, C can sit both first, C can sit both in the first and second row. Okay, I hope it's clear. Now, so 5 can sit here, A, 5 can sit here, B. The remaining 10 C will 5 here, 5 here, C, C. So all 20, the total is 20. 20 monkeys can sit. If I go to the second test case, so basically understood, right? First you need to place A, then you need to place B, then the rest of our places can be occupied by C. Now if you check the second test case, now the row size has reduced to 3 and 3. Now A is 6, but 6 means A can't sit entirely here, right? Only half of the A can sit. That means only 3 from A. This entire thing is occupied by A. Though we are having 3 more options in A, they can't sit in B. So obviously here A is greater than M. So need to handle this case. In the second row, one person of B, one person of C, and one seat is still empty. So that means total of 3, 1, 1, 5, which is correct. So the problem is quite simple. You can also go through the other test cases. First, you need to make seat A and B. So in your answer, first will be like max of A or M plus max of B or M. But you need to also add the count for C, right? For that, you need to calculate how many seats are empty in total after placing A and B. So we can get it like something like this. The leftover seats, can I say it as M minus A and M minus B? But yeah, if you see in the second case only, M can also be less than A or M can also be less than B. So to handle this, I will compare it with 0. So yeah, this should not be max here. It should be minimum. So out of, if this goes negative, you should consider 0. That means the entire row was occupied. So maximum of these two. This gives you the count for leftover seats. In this place, you can you can like make C students. So this can be like leftover seats comma C minimum. Okay. So let's try to write the code. So right now, I think int variable will be sufficient. I'll just zoom in. So I need to take M. The same thing I need to do it for ABC. So in the answer, first of all, we need to calculate the leftover seats. Leftover seats is nothing but m minus a comma 0, m minus b comma 0. So these are the count of leftover seats. You also need to find the answer. Answer is seats occupied by A. So maximum of B and A. Seats occupied by B. Maximum of M and B. And the count of seats occupied by C. Math dot min of leftover seats or the C. And yeah, let's just try to check our answer. Copy the test cases. Let's wait for the output. So by seeing the test cases, the limits on it, we might have to use maybe. Okay, the test cases are going till 1 second, so I think it should be majorly fine. Let's wait for the output. Okay, we got the output 25, 32, 84. Is it the same? 25, 32, 84. Let's try to submit the code. Okay, I think there is some issue. Okay, but yeah, it matches the output. You can just cross check later. Okay, so let's start with the other problem, harder problem. So here you're basically given, like, you're given a sequence of positive integers, and with and here they have given a definition for mode. Mode is a sequence. Okay, mode of the sequence if it occurs the maximum number of times. So in this case, 2 3 2 2 3, the mode is obviously 2. But in this example, where the every element is occurring equally, so you can tell us any one of them can be mode. So you okay, there's a person, I guess UFO. They have given you a string A of length n. They want you to construct a string B. They want you to construct an array string. You have to construct an array B of length n such that A of I is a mode of sequence till B1, B2, Bi. For all I starting from 1 to n. Okay, fine. So basically, they are telling you to create a array B from A where it is following this one condition. So the test cases are like going to 10 power 4 and is going to 10 power 5. A is always less than or equal to n, and in the output also the B will be less than or equal to n. It should not cross n. So which is fine. Let's see the test cases here. So if you see, in the first array till here, okay, 1 is the input which is required. Till here 2 is the mode which is correct. But let's try to go to the second array. When you see this, okay, for this 1 should be the input output. But when you come here, you can still have 1. At this point also you need the 1 as the mode for 0 to till this point. But here we are keeping 2. Why? Because the next time we want 2 as the mode. If you keep like 1 1 and again 1 in the output, and for the fourth point when you want 2 as the mode is not 2, it's 1. So to handle this we are keeping here 2. Okay, so we also need to see the future values. If I see the third array, 4 5 5, let's directly go for the bigger example. 1 1 2 2. um so so this is the, let's say, 0 1. So um at this point we definitely want 1 as the output array. But at this point, if you keep again 1, you won't get 2 here. So we understood we should keep 2. But if we go on keeping like again 2 here, from here till it is okay. Here also it's fine, we can keep 2. But here, even if we keep 1, our mode is not going to be 1. So that's why we can also introduce this 8 if you observe. 8, is it present in the array? No. So we can tell that A is something called as unused number. So we can keep any number x1. Here we can keep 2. Again, when we reoccur the already used number, we should not print it again. We can go for like maybe some other number x2. Then again, we don't need to keep 1 again. Why? Because if we keep 1, there can be a chance that in future we can't find the correct answer. So we'll keep like some x4, x5. When you get 3, 3, x6, x7, and x8. In this case, we can see that okay, we are using 1, 2, 3, but we also need few other values which should be less than n, and our n is here 10. So here the used numbers are 1, 2, and 3. The unused numbers are 4, 5, 6, 7, 8, and 9. And you can also consider 10. In place of x1, x2, and so on till x8, we need to place either of these values. So something like we can replace x1 with maybe 4. Now it is used. This was unused. x2 I can replace it with, let's say, 5. x4 with 6. So add 5 here. Add 6 here. x5 with 7. And similarly, this with 8, 9, and 10. So we somehow need to keep n numbers. We need to keep n numbers in this array. Okay. So let's write the code. So in this, in our input, we are given n followed by the array. Int array. Let's declare our array. Let's take the array in the input. Yeah. Now we need to keep track of unused elements, or let's say used elements. So I need a boolean array. Let's name it as used elements. So this size can be like n plus 1. Why? Because I am going till n. So it will be like size of n plus 1. What else do I need? Okay, this is boolean. My bad. Now we need to print elements in the B array. So for now, I will be iterating from 0 till n. I will just zoom in my code a bit. If it is used, if it is not used, if my array of I, if it is not used, then I will just print it. Okay, system dot. I will just print my array of I. Okay, since I am printing in the same line, it should be simply system dot print. Followed by, since you have printing now, just mark it true. We can use this used boolean array. Why? Because we know that all the elements are in the range of n. So mark it as true. Now, if it is unused, okay, let's say if you array of I, if it is, let's say, used, it is true. We should not keep the same element. We should next focus on the next unused element. To track the unused element, I will take a variable, let's say unused, and the minimum element can be 1 as per the constraints. So till I find the unused element, till I find um, the unused element. Okay, till it is true. Okay, till it is false. Or let's say till it is true. Till I find unused element, I will simply increment the unused variable. As soon as I find the unused element, I will break the loop. I will print the unused element. Okay, I will print the unused element and I will mark it true. And I will mark it like let's say true. So in this way we can cover like all the elements from 1 to n and without repeating any element so that we don't have any risk in the future. Let's copy the sample and check if you're getting the output or not. Okay. Okay, we have declared the variable a. Okay, so we are getting, and yeah, we are not following this thing here. Once you're done with the array, just print a new line. Let's check, are we getting the correct? Okay, it says like 1 2. But yeah, so yeah, ideally, though it feels like it's not matching, but there can be multiple possible answer as you say. If you cross check with the input, 1 2 is correct, obviously we know that. But when you come here to the second input, 1, yeah. So 2, you can also print 2 here, which is okay. But if you see at this point, what is the mode? It's still 1 2 3 4 everything. So this also satisfies the given condition. Though it is not exactly same as the output here, there can be multiple possible arrays, out of which this is one of the possible arrays. Okay, so you can cross check the code. So there's some, I think the contest is frozen now. So let's go to the other problem. So let's start with the fifth problem, insane problem. So in fifth problem, they're given like you're given five numbers, and in that you need to find number of ordered pairs x and y such that x and y have this range and they should satisfy this property with the value in. So take a time, read the problem statement a minute, and try to understand this problem statement. The input for test cases are like going to 10 power 4 and k can go to 10 power 9. The same with ranges of 10 power L1 and R2. In output, you need to print the number of xy's. That's Let's see the example. So in the example, if you see, so this is your L1, R1, L2, R2, and this is your M value. Let's consider the first case. For for the value of k, for the value of k, my k is equal to 2 here. That means my k power n in general, can anyone, like, if you understand, k power n is nothing but like it, the minimum value. Can I say the minimum value for k power n can be like greater than or equal to 1? If my k powers have 0, it can be 1. If I have k equal to 1, he, in this case, it can be 2, and 2 power 2, and so on. We can have n values minimum starting from 0, and it can go till infinity depending on the question, depending on the limits and all that. So if you try to understand, you have 2, 6 as a range of x. Okay, so as a range of x, and you have 2, 12 as a range of 5. You need to find numbers such that they satisfy this thing and equal to k power any random value n. Okay, by saying this, by saying this, the brute force, the naive way for doing this is fix one pointer here, starting from the limit of L1, and move this pointer till R2. Every time you fix this pointer, fix another pointer on the range of y. So check, is my 2 by 2 is equal to any k power n. So let's say my n is equal to, initially, let's say for the value of n equal to 1, or let's say 0, does this satisfy 2 power 0? Yes. So now move your pointer. Does this satisfy 3 power, okay, 3 power 2 to 2 power 0? No. So in this way, you should go on checking, which will obviously give you time limit exceeded for the given constraints. So now, to optimize this, first of all, we need to solve this equation. If you solve this equation, if you just change this equation, like, I can write the equation as x equal to y by k power n. Why? Because we know, right, the minimum value for k power n can be greater than or equal to 1. Then depending on this n value, we are going to iterate on the range of k. Okay, so this is one thing we know. We also know the range of y. So can I say that x belongs to the range of y, that means L2 by k power n and R2 by k power n. So this is the upper limits, the maximum of x. So by this, we understood that x has the values in this range. But while comparing, we also need to compare this with L1, this with R1. Why? Because we need to find out the upper limit of k power n and this is seal, and lower limit for k power r power n. This is floor. So yeah, mathematically we can write this in this way. But while you're playing with the real numbers, you can write this as R2 by k power n. But you can't write this as But you can't write this as like simply R2 by k power n. Why? Because there will be some edge cases. So we'll write the standard form for the C. So this is completely mathematical thing. So these are the upper limits of lower bounds. These are the upper limits for lower bounds. For x min and x max, you can say this is like x min, x max. So while comparing, we need to also compare with L1 and R1. And out of L1 and L2, you need to consider the maximum limits. Why? Because if your L1 is somewhere over here, your L2, this entire value, if it is somewhere over here, L2 minus k power n plus 1 by k power n. If it is somewhere forward, out of these two options, you need to consider the rightmost one, the maximum one. Why? Because there may be chances like you might not have that possible answer. There might also be a case where this L1 can be ahead. So out of these two, you need to consider the maximum one. When you come to R2, you need to consider the minimum one. There can be a case where your R1 is somewhere over here and your R2 is somewhere by like this. So out of these two, you need to consider the lowest one. Or there can be a case where your R1 is more behind. In this case, you need to consider this one. So this problem is like more dominant over what we can say max. But yeah, you can also solve this instead of going towards the equations. If you want to find out seal and flow, you can also use binary searching. Oh, so let's try to code this up. So you need to find out the x min, the x max, and whatever you get the value, you need to include both of them. Uh, these are the limits of your answer. So x max minus x min plus 1. Every time you need to add this to your answer for every possible value of n. Or let's say k power n. Okay. So yeah, this problem obviously takes some time to understand. So yeah, try to understand, and most probably if you go through one or twice, you'll be able to grab it up. Let's try to code it up. So in this case, our input is like 5 numbers. So no need of this entire thing. So I will just zoom it a bit. Yeah. I am given the value of k. I am not given the value of n. N can be any value. I need to take inputs of 4 integers. But yeah, by seeing the constraints, you can also go for taking long. It can also help you. So better to go with long. Long, you need L1. You need long R1. And you need to next take L1 and R1. So simply let's say next. For every possible value, okay, first thing we need an answer variable. Next, to get the the lowest possible value of n is 0. So my largest power can be 1. K power, any k power 0 is 1. So while, and yeah, there is also additional condition, right? If you check the examples here, if you go through the examples, there is also a hidden condition. There is there is a condition like R1 is always less than R2, and moreover, your k power n should always be less than or equal to R2. It can't be beyond this. Okay, so this is also a hidden condition. So while my L2 is greater than, oh my bad. While my P is less than or equal to R2, continue. Then every time whatever the P powers you have, get the min and max. So x min, math dot max of your L1 and L2, L2 plus P minus 1 by P, and your x max math dot max of R1 comma R2 by P. So there can be a thing like sometimes your x min can be greater than x max. So better to check if your x min is less than or equal to x max. So simply add to your answer your x max minus x min plus 1. Why? Because both x min and x max are included, and then increase the power p into q. Yeah, at the end print your answer. So let's try to check our code. No semicolon. Only one error. Uh, do we have any other errors? Yeah, I guess so. No. So are we getting the same answers? Okay, okay. Okay, we need to consider here minimum of both. Are we getting the same output? 12. Yeah, we are getting the same output. So yeah, let's try to even run the code. Let's see if it gets submitted. Yeah, cool, it got submitted. Thank you for watching this video. I hope you have liked it. If you have liked it, like, share, comment, subscribe. Mention in the comment box like which content you want us to create. And yeah, thank you once again. Meet you in the next video.